Imagine the ultimate cosmic horror. Not an alien invasion, not a black hole swallowing a galaxy, but something far more intimate, far more chilling. Our own star, the very source of life and warmth, turning into a silent, dead husk, and then eating its own children. It sounds like scene from a sci-fi epic or a horror, but in the vast, unforgiving darkness of the space, astronomers have just witnessed exactly that. A white dwarf star, the ghostly remnant of a sun-like star, caught in the act of devouring its former planetary system. This isn't just a stunning observation, it's rewriting the very rules of how star dies, what happens to the rules of the universe, and if the world is left behind. So, friends, welcome to the death of the starlight. To understand this cosmic tragedy, we first need to understand the star at its own center. The white dwarf, which is our sun will eventually become. Our own sun in about 5 billion years will eventually become a white dwarf. Stars like our sun spend billions of years fusing hydrogen into helium in their cores, generating the energy that makes them shine. But this fuel isn't infinite. When a star like the sun runs out of hydrogen in its core, it begins to die. It swells into a massive red giant, engulfing all inner planets, potentially even Earth. Then it sheds its outer layers into a beautiful planetary nebula, leaving behind only its super dense, super hot core. This core is the white dwarf. The it's roughly the size of Earth, but contains the mass of entire Sun. Imagine squishing the Sun down to a size of a city. That's the kind of density we are talking about. It's no longer actively burning fuel. Instead, it slowly cools over trillions of years, a glowing ember in the cosmic night. For a long time, we thought these dead stars are relatively peaceful, silently fading into oblivion. But recent discoveries are telling a very different and far more violent story. Enter the villain of our story, which is our current tale, the specific white dwarf star, approximately 3 billion years old, located in a system far, far away. For years, the astronomers have observed some white dwarfs that seems to pollute their atmosphere, containing heavier elements like iron, magnesium, silicon, etc. Elements that shouldn't be there. White dwarfs are primarily made of hydrogen and helium, so their heavier elements, discovery was a mystery. Where were these coming from? The leading theory was that these elements were the remains of the planet, asteroids, or comets that had once orbited the star, but observing the actual process of a white dwarf consuming their remnant, that was a holy grail until now. Recently, using some powerful telescopes, astronomers observed this particular white dwarf, and what they saw was an unprecedented, facts. They didn't just see the remnants, they saw the accretion happening in real time. This 3 billion year old white dwarf wasn't peaceful at all, and it was not cooling peacefully at all. It was actively, ferociously devouring material from its former planetary system. It was a cosmic feast, billions of years in the making, playing out before our own eyes. It's a truly cannibal star. When a sun like star transitions into a white dwarf, its immense gravity remains. In fact, due to its small size and extreme density, the gravitational pull at its surface is millions of times stronger than of Earth. Any planet, asteroid, or even dwarf planet that survived the red giant phase or formed out afterwards would still be orbiting this incredibly dense remnant. But these orbits are often disrupted. Perhaps gravitational nudges from other surviving planets or even distant stars can send these objects spiraling closer to the white dwarf. As an object like an asteroid or a planet gets too close, the white dwarf's powerful gravity starts to tear it apart. This isn't a gentle process. The side of the object closer to the white dwarf feels a stronger gravitational pull than the side further away. This difference in pull, called the tidal force, stretch and distort the object until it literally disintegrates into a stream of rocks and metallic fragments. These fragments then form a swirling disk of debris around the white dwarf, much like the ring of Saturn, but made of planetary shrapnels. Slowly but surely, over billions of years, these rock and metallic pieces lose energy, spiraling inwards until they are finally pulled down onto the surface of the white dwarf. This is the accretion process. The star is quite literally eating its own planets, one atom at a time. The evidence of this cosmic meal is incredibly precise. When astronomers observed this particular white dwarf, they analyzed its light using technique called spectroscopy. Think of it like a cosmic fingerprint. Every element, when heated, emits or absorbs light at specific wavelength, creating unique lines in a spectrum. In the atmosphere of the white dwarf, they didn't just see the usual hydrogen and helium, they saw prominent spectral lines of iron, magnesium, silicon, oxygen, and other heavy elements. These are the building blocks of the rocky planet. What's more, they could measure the speed at which this material was falling into the star. They could tell that there was a constant ongoing influx of these planetary fragments. It was direct, irrefutable proof of the white dwarf actively accreting materials from its destroyed planetary system. This wasn't just old pollution, it was a live event. A 3 billion year old star still actively consuming its world. This observation is more than just a cool space fact. It fundamentally challenges our long held assumption about the late stage of the stellar evolution. For decades, the prevailing theory was that once a star becomes a white dwarf, things quiet down. Any remaining planets would simply orbit the dead star, perhaps frozen and lifeless, but largely intact. The idea of ongoing active planetary destruction billions of years after the star's initial death was considered less likely for a large planet-sized object. It was thought that most of the planetary material would either be engulfed during the red giant phase or ejected. But this new discovery proves otherwise. It indicates that gravitational chaos in these post-main sequence systems can persist for billions of years, constantly disrupting and dismembering planets. This means the destiny of the planetary system around a white dwarf might be far more violent and drawn out than we ever imagined. It tells us that the planets can indeed survive the red giant phase, only to face a slower, more gruesome death by the tidal shredding. It forces us to reconsider the entire life cycle of a planetary system from birth to what could be a very drawn out dramatic end. This naturally leads us to chilling question. What about us? What about our solar system? What about Earth? In approximately 5 billion years, our sun will also exhaust its hydrogen fuel and begin its transformation. It will swell into a red giant, possibly engulfing Mercury, Venus, and perhaps even Earth. And even if Earth isn't completely consumed, it would become an uninhabitable, scorching husk. Its ocean boiled away, its atmosphere stripped. After the red giant phase is over, the sun will shed its outer layer, forming a beautiful planetary nebula, leaving behind a white dwarf, our sun's dense Earth-sized core. While Jupiter, Saturn, Uranus, and Neptune survives, probably though their orbits might shift. And what about the asteroids in the asteroid belts or the comets in the Oort cloud? These smaller bodies will definitely persist. This new research suggests that even if Earth does escape the initial engulfment, or if the large planet like Jupiter survives, there might not be as safe forever. Over billions of years, gravitational disturbance could send them spiraling inwards towards our sun's white dwarf remnant, where they could face tidal destruction, becoming raw material for cosmic feast. Our beautiful blue planet ultimately torn to shreds and absorbed by its dead parent star. The implication of this discovery stretch far beyond our own backyard as we discover thousands of exoplanets orbiting other stars, and this research provides a vital clue about the ultimate fate of those distant worlds. If the planetary destruction is a common, long lasting process around white dwarf, it means that many planetary systems, even those that seem stable, could eventually face this dramatic end. It tells us that the universe is not static, it's a place of constant change, destruction, and recycling of material. Furthermore, this helps us understand the building block of the planets. By studying the polluted atmosphere of white dwarf, astronomers can actually analyze the chemical composition of the planet that used to exist around the stars. It's like a cosmic autopsy, revealing the ingredient of the planet that are now gone. This gives us an invaluable data on planet formation and the diversity of the planetary composition across the galaxy. It's a bittersweet science, studying death to understand life. So, death by starlight, the white dwarf eating its planet, is more than just a catchy title. It's a stark reminder of the immense power of the relentless cycle of the cosmos. It paints a picture of the universe that is both incredibly beautiful and terrifyingly different. This 3 billion year old white dwarf, quite yet powerful, consuming its former children, forces us to rethink the very concept of the star's death. It is not a peaceful fade into a darkness, but for many planets, it's a drawn out, violent demise. It's a testament to the fact that even in the vast emptiness of the space, destruction can be prolonged, dramatic processes reshaping solar systems long after their brilliant suns have extinguished. The universe continues to surprise us, challenging our assumptions and revealing its secret, one devour planet at a time. So, friends, what do you think about this ultimate fate of our solar system? Let me know in the comments below. And if you found this journey through cosmic cannibalism as fascinating as I did, be sure to hit that like button, share this video with your fellow space enthusiasts, and subscribe to our channel for more deep dive into the mysteries of the universe. Thanks for watching, thanks for joining live, and I will see you in the next cosmic adventure. Bye for now.